Okay, if you move a mass vertically from point A to point B, so the trick here is to figure out which one is below the other one. Then these are easy, right? If it's a mass. Okay, so let's see. The potential changes from negative something to positive something. So negative 12 goes with this guy, and 23 goes with this guy. So B is higher, right? Here's B. B is at 23.0 joules per kilogram, and A is at negative 12 joules per kilogram. Okay, we got this. Okay. So the field points, well, the field points down. Gravitational fields point down. So the field points from, by the way, from the positive to the negative, right? There it is, right? Okay, so the field points toward A. I'm starting randomly here, right? Okay, which point is at a higher elevation? Well, B is at a higher elevation, right? Okay. That's just because A's got a more negative potential, B's got a more positive one, right? It's higher. Okay, the field is toward A. And then what force does the field exert on a mass? Okay. Okay, so let's see. I think I'm going to use this. G is the opposite of change in Vg over change in R, right? Okay. So G is the opposite of, oh, R, okay, I get it. Okay, so our change in potential from A to B, okay, let's say that's A to B, okay, is positive 35. The opposite of positive 35, and that's joules per kilogram, right? And our displacement was that we went 17 meters. There we go. So I displaced myself this way, right? This is my displacement. That's my S. Okay, and my change was a positive 35 joules per kilogram, and there we go. So our G is 35 divided by 17, and that's 2.0588. And this is now newtons per kilogram, right? Because remember, a joule is a newton meter per kilogram. We divide by meters, we just end up with newtons per kilogram, right? And it's going to be down, right? The negative means it's down. Okay, well, they're all down, right? Okay, so let's see what else. Okay, oh, we want to find the force. Okay, so the force is, we have a 5.2 kilogram mass, and now I'm using G is F over M, right? So negative 2.0588, there's a comma in here, is equal to force divided by 5.2. So I guess I multiply these guys, right? So times 5.2, and I get a force of negative, the force is negative 10.7 newtons, which means it's, of course, down, which is kind of stupid because it's a gravity problem. Which way would the gravitational force be otherwise, right? Okay. So again, how do we know which way the field is? Well, the lower potential is literally lower. It's lower in elevation. This is easy, right? Higher potential is higher, okay? And so the potential goes from high to low in a gravity field, and B must be higher. All right.